you need to know whether you can make that number up with those.
Okay, let's do struct-d. I think I'm gonna buy this course right here. I think I'm gonna buy this course because I've been through almost all the free stuff and everything is gold. I love the way he explains things. It's just really good. So let's look at this one. Write a function fib that takes a number argument. I'm gonna open up Excalidraw because every problem I would like to be able to draw the visuals of every single problem so that if I'm in an interview, I can work through a drawing pretty easily. Or I can explain myself easier because I'll be able to represent what I'm thinking in a drawing. And so the more I draw these types of problems, the better I'm going to be in the interview when it comes to when it comes to the whiteboard stuff. Also, it does make it really easy to do the problem if you can nail down the visuals. Let me paste this right here. I also wanted to maybe work on creating some sort of animation using Framer Motion and React to visualize some of these problems. And I think that would be a good side project. Write a function fib that takes in a number argument and returns the nth number of the Fibonacci sequence. The 0th number of the sequence is 0. First number of the sequence is 1. To generate further numbers of the sequence, calculate the sum of the previous two numbers recursively. So I know in the dynamic programming section, and you could think of Fibonacci both in terms of memoization and tabulation. So let's first think of it in terms of memoization. And I watched his previous videos and I wrote notes on the previous video. So let me take the previous notes to kind of refresh myself. We have two recipes. We have a memoization recipe and a tabulation recipe. And so let's scroll down. Memoization, tabulation. So we can start with memoization. Oh, I forgot to copy the mother. Let me scroll out because it makes it go faster. So I need to copy this. Boom. Wait, why is it not pasting? Hello? Copy, paste. Okay. Just drag it down. As you can see, I've done a lot of visualization so far, and it definitely helps. So I'm getting quicker with using Excalidraw. I really like this program. So maybe I'm gonna put this to the side. Let's keep this right here. Oh my gosh. Let's copy all this and move it to the side. And so memoization. We have to visualize the problem as a tree, implement the tree using recursion, and test it. Then we need to make it efficient. So let's visualize this using a tree. So we take in an argument n and return the nth number of the Fibonacci sequence. The 0th number of the sequence is 0, and the first number is 1. So those are base cases. And to generate further numbers of the sequence, we calculate the sum of the two previous numbers. So how do we visualize this? We can first start with the input of n. So let's say 5 is the input, n equals 5. Right. Then what are we doing? Well, we have to, we have to break the problem into subproblems. And the first subproblem is zeroth number of the sequence is 0, and the first number of the sequence is 1. We can think, okay, the first problem is, how do we find the 0th number? Is it just return 0? The first number, you return 1. And then the second number, how do you find the second number? Well, you return the sum of the previous two numbers, so 1 and 0. And so the second number would be 1. And then the third number would be the sum of the previous two numbers, which is 1 and 1. So that would be 2. And you keep going onward. And so what does that look like? So in terms of the tree, we're doing the subproblem of, or first we have the problem of, okay, what is a Fibonacci of 5, right? What is fib of 5? But to get fib of 5, we need to get, to generate fib of 5, we need to calculate the sum of the previous two numbers. And to calculate the sum of the previous two numbers, or the Fibonacci of the previous two numbers, or the previous two numbers is the subproblem of 1 less. And 2 less. Right? 1 less and 2 less. And then when you add those together, you get the previous, or you get this number, right? And so, but each of these also took a certain, took that same formula to get to each of these, right? So to get to fib 3, you need to add fib 2 and fib 1. And to get to fib 4, you need fib 3 and fib 2. And then And to get to fib3, also we're doing fib2 and fib1. And we're already seeing some repetition. So it's bringing back my memory of why or how we can memorize. And so fib1, or fib2 is fib1 and fib0, right? The previous two numbers, fib1 and fib0. And fib1 would just return 1 because the first number of the sequence is 1. And the 0th number is 0. So fib1 and 0. 0, 0, 0, and fib1, and then fib1. So like we can now add the numbers here of what each number returns. Let's make it red. So this returns 0 and this returns 1. You have to add them together. Let's keep going, 0 and 1. 1. 0. 1. And then when you take the sum of them and you return it, now this fib2, we can see that fib2 is 1. And you can see here fib2 is 1, so you can add that value to all the returns of fib2. And so here we have fib1 and fib2. They're both 1. And so when you add both together, fib3 is 2. And this is also, yeah, this is fib3, so it's 2. And fib4 is 3 plus 2, so it's 2 plus 1 is 3, so we have 3. And so we have fib2 is 1, fib3 is 2, fib4 is 3, and fib3 should be the sum of fib3 and fib4, which would be 5. So fib4 is 5, or fib5 is 5. So this should be equal to 5. Right? So the sequence, then the solution should be 0, 1, 1, or this should be the Fibonacci sequence, 0, 1, 1, 3, or 2, 3, 5, where the number, the further number, is the sum of the previous two numbers. So 0 plus 1 is 1, 1 plus 1 is 2, 1 plus 2 is 3, 3 plus 2 is 5, right? So this is the recursive tree. And so how do we code this out? Well, I know that every branch is a recursive call. And what are we doing in these recursive calls? Well, we're subtracting n to get to the previous numbers, right? And we need both the sum of the first previous and second previous. So we have base cases too. So if once we get down to the bottom of 0 and 1, it's not going to be able, we're not going to be able to do the sum situation. So of the two previous numbers is there's no previous numbers. So we say if n is equal to 0, then we want to return 0. If n is equal to 1, then we want to return 1. And else, we're in the range of like 2 to 5. And so what we want to do is return the Fibonacci recursion of n minus 1, so the first previous number, the sum of n minus 1 to fib n minus 2. And so these two recursive calls represent these two branching. And we're going to do that at every function call. We're going to branch twice. And so the complexity of this would be complexity of this would be 2 to the n, 2 to the n, n being 5, right? So every two to the n. So for example, here we have 5 and we have 2. So 2 to the n would be 32, right? 2 to the n in this situation, 2 to the n would be 32, am I right? 3 would be 8, 4 would be 16. So is there 32 here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Did I do that wrong? Did I do that wrong? So I think it's to the n. Or maybe it's 2. Maybe n is not 5. Is n 5? I know we're making two different calls. All right, let's look it up. So what is the complexity of Fibonacci series? Maybe that's ChatGPT. ChatGPT, what is the complexity of Fibonacci series? What is the time complexity of the Fibonacci series? So it is 2 to the n. And why is it 2 to the n? Y is the time complexity to n. Apologize for using my previous response. The correct time complexity of the naive recursive approach from computing is actually exponential, not to the n. That is exponential. Total number of recursive calls. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. In this situation, n is 5. It's not necessarily 32 calls. Am I missing something? Fib2, Fib1, Fib3, Fib... Oh, yeah, Fib3, Fib2, Fib2, Fib1. Let's see, y is time complexity of Fibonacci sequence 2 to the n. Trying to find the complexity of Fibonacci series using a recursive tree, included height of O to the n. How come it is 2 to the n? Is n being the height of the tree, right? Height of the tree. Yeah, it's not the number put in, it's the height of the tree. So it'd be 1, 2, 3, 4. So yeah, it's about 2 to the n. Height of the tree being 4. One, 2, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Plus 14. Nah. Yeah. Anyways, so that's the time complexity. And being the height of the tree. Let's write that down. Let's go like this. 2 to the n. Maybe put h. Let me just test my audio real quick. Okay. Okay, so this is the recursive visualization. And this is the code. And so everything was good except execution timed out because it's slow. And so in terms of memoization, we visualized the tree as a problem, we implemented the tree using recursion, and then we just tested it and everything's good, except we need to make it more efficient. We need to add a memo object, add a base case to return memo values. Store return values into the memo. And so what we want to do because we have repetitive situations here, we want to take advantage. For example, this right here happens multiple times. So we want to use memoization to keep ourselves from performing repeated actions like fib2 and fib3. And if we can keep ourselves from repeating these, fib2 and fib3, then all we need to do is these two, right? That's all we really need to call. And or once we get down to, because it's going to go down this way, once we get down to this way, all these other calls don't have to be, we only have to do it once. So the way we could do that is by using memoization. We create a memo. I don't know if we could do this in Python. Can we do this? Equal to a dictionary, anti-dictionary, all right? And want to make sure we pass the memo into the function. And we want to say if n in memo, not in memo, then we want to add it to the memo. The tree is not complete, hence the size is not the power of 2. By the way, Python, you could just use cache annotation. What is cache annotation? Like, what does it do? Does it do the same thing as what I'm trying to do here? And the tree isn't complete, so yeah, that's what I was thinking. I think I didn't complete it. So 5, 4, 3, 3, 2, 1. When you say the tree isn't complete, am I supposed to have like fib of 0 like is this how I complete it? Like this? Or was there something else I was missing? It does the memoization. All right, let me look that up because I've never seen that before. I've never seen cache. cache, Python memoization. Oop. Memoization is a specific type of caching. Here is the memoize decorator that implements the above caching algorithm. What? This decorator takes a function and wraps. Is this the same thing as the add cache? I'm so confused. I just don't see the at cache. I don't know if that's the same in this article. Write at cache before the function def and it'll be fast. Oh, that's it? Like just like, do I have to import it? Let's see, let's delete this for now. It's not defined. Let me see. Import cache decorator. I don't know what that's called. Decorator Python. Memoization is caching, yeah. Add cache, okay. From FAANG tools, import cache. From FAANG tools, import cache. It's not working. Anyways, let me try and do it manually because I guess that's the point of the problem anyway, right? And so we create a memo. And we say if n not in memo, then we want memo n how does this work? We want memo n how does this work? What are we saving? We're saving, regarding the size of the tree, I'm saying that it's not to the h. When you say, so you say it's not to the h, is it because I didn't put, like, I didn't extend it to fib0 here? Like, was I supposed to do this? Or did I miss something else? Not talking about the diagram. Um, 2 to the, where did I get 2 to the h? Well, the height of the tree, isn't the height of the tree like how many calls down? And so, and then what I was trying to do is match, I guess, how many branches I was making. And right now, I'm making 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, like 14 branches. I don't know, but I guess I'm just lost on how, maybe this is, yeah, like this is not right, but I'm lost in how to calculate, or yeah, how to calculate how many branches. Because right now it's only 14, but I don't know if I just missed branches. That's only true when all branches have the same length. Okay. So when we're talking about time complexity of this recursive solution, what is the time complexity? The rightmost branch only has length 2, but the leftmost is longer. Yeah. So when we're talking about time complexity, we just say 2 to the n. And is n 5 in this case because we input 5? Like, is it 2 to the 5? It's not a power of 2. So that confuses me because I thought so what would the time complexity be? It's interesting because the size of the tree follows the same recurrence. Size of n is equal to 1 plus size of n minus 1 plus size of n minus 2. It's a power of the golden ratio. What's the golden ratio? Golden ratio. Oh, okay, I see. As an estimation though, do you say 2 to the n? Or is that still not? So like as an estimation you would say 2 to the n, but it's not gonna always be that. And so that's why there's not 2 to the n. Different branches. One 1.6 to the n. Ah, I see. Okay. All right, so in this thing, we set the memo of n equal to how do we do this? We set the memo of n equal to, like if n is equal to 2, if n in memo return, we have to set instead of returning, that's what it was. Instead of returning, we have to set the previous solution to the memo of that instance, and then you just return the memo. And if the number is already in the memo, so if n is in memo, we return n, or return the memo of n. Otherwise, we have to set the memo in the current instance, and then we would just return that entry. If n in memo. I see, okay. So that would be the memo oh, I messed up. Where did I mess up? This doesn't work, huh? So let's do what they did here. Fib n memo and def fib n fib 5 empty dictionary, right? Or it's not 5, n empty dictionary. What did I do? calling the wrong thing here. No. Okay. It's exponential. Okay, I see. Complexity Fibonacci. So this is what you were saying earlier. The upper bound is 2 to the n, but this is not the tight upper bound. But the fact that Fibonacci can be mathematically represented as linear recursive function can be used to find the tight upper bound. And this is how you find it. Do you do recurrence relations a lot? Like, are you into discrete math? Do you like to solve these proofs or find these recurrence relations? I was watching the MIT lecture, and they would go deep into that concept, recurrence relations. All right, so that's memoization. Now we have to do we can look into tabulation, but I guess we'll just do that later. But let's see like his approach.
Hey programmers, Alvin here. Right now I want to work through this fib problem. Of course, we're referring to the classic Fibonacci sequence. This is a really, really important, computer science problem, and to me it serves as the foundation to really unlocking a few harder concepts down the line. So even if you've done this fib problem before, it helps to review it together right now. We're going to see this core pattern show up a lot during the course together. And so let's start by understanding what we should do in this problem.
Yeah.
Well, we know that the Fibonacci sequence has a few certain seed values. We say that the first number of the sequence is 0. And
I mean, I like to do solve problems on my spare time too, but I'm not that deep yet. I have a lot of like I used to go through the discrete math textbook and read through it and solve some of those problems in there.
The second number of the sequence is 1. And then to generate further numbers of the sequence, we just take the sum of the previous 2.
Yeah, I think I was you changed your name, right? I think I was you followed me, and I think I was watching your stream, and you were going through some problems. And it looks like you have a lot of experience with Leetcode. I'm just trying to go through the major problems so that I can be prepared for interviews. There's this guy right here. I love the way he explains things because he goes through them visually, and that's I guess how I like to learn, or it works for me for these problems. So I'm just going through his course. His name's Alvin Zablom, and yeah, I think I'm gonna buy it because I'm almost through the free stuff, and it really opens my mind because when I go through Leetcode problems, I have the references in my mind from some of this stuff that I've learned from these videos, so I can understand, oh, this is a certain type of problem rather than being completely blind and just stuck. So this, Leetcode is another resource I've been using to actually just look at the problems themselves. Or I'll do this. So like, yeah, I've been working my way through and just writing notes on the problems. And another thing that I wanted to try was this site right here, because I also can code in JavaScript and TypeScript. And so if they have these type of questions, like front end questions, or something in the middle, maybe system design or something like that, like I want to be prepared for those as well. They also have like these JavaScript questions are or not JavaScript, but they have data structure and algorithm questions on here too, like coding questions. So I also wanted to see if like if I really like this site and I'm going through the problems, maybe I'll do this. Like I have, a clean resume, but I don't have any projects. So I don't know if they're just going to be like, oh, you need to get a project, but yeah, I don't know. I might try this and see if there's good feedback. The thing is, it's pretty pricey, $400. You'll stream more often and teach as much as I can. Yeah, man. I'll look into your streams and try and learn from them, because I've just been watching random people on YouTube as well. So if you go through like some of the problems that these companies are looking for, then I'm definitely watching. Clean meaning like it's not going to be grammatically it doesn't look ugly, but it's not like I've filled with experience. So I guess I can show you. Hold on 1 second. So like I have a summary that explains that I've worked with React, TypeScript, that I've built a portfolio site. I have my portfolio site here, but like there's nothing crazy on there, just a couple of toy sites that I built. And I have some previous work experience as a product manager, like as an independent consultant for a contract. And then I built an e-commerce site for for a customer, and then some hackathon and school projects. So like it shows that I've been coding, but nothing like, I guess, concrete that they would, or I'm not getting any calls, so, or getting any feedback. Like I just keep getting denied. So I need some help on what I need to do other than building some sort of project that I may not be able to build. I mean, I can try it, like at least if they gave me some information of like, if you build this project, this one project or two projects, if you build these two projects, you're going to get calls, then I would work on those projects. I just don't know what to build. Like this is not, having a portfolio site is not good enough, I guess. And having these side little example projects are not good enough for me to get calls. So my experience, and then I just don't have experience. So I don't know what they are going to give me in terms of information from taking my portfolio to that. Like what is this personalized guidance, or I see here it says it reviews GitHub, resume, portfolio, website, projects will be reviewed. So like, yeah, I don't know what they're going to tell me. Like, oh, I just need to build more projects. So if they give me literally no one, so I'm not just applying to FAANG, but like to companies around me in Charlotte, North Carolina, and I've talked with some recruiters, that recruit. So a lot of the companies around me are banks, Wells Fargo, Bank of America. And so I applied directly. Lowe's is another one that's around me. I applied directly to those companies, and none of them return, or they denied it. And then I've worked with recruiters, and they always ask for like 5 years of experience. So none of those worked out. But they said, like, the recruiters would say, okay, I'm going to send your application in, and I guess the managers don't accept it, or I don't know what's going on with the recruiters. Other than that, I'll just look through LinkedIn and try and apply to ones all over the world, or not the world, all over the United States, and try to apply to different, like, what looks like to me entry-level jobs. But even the entry-level ones, I guess they require more experience. But yeah. I think I'll try to apply. I'll try to apply to something. Well, then there's a lot of like scam things. Like, I can't tell if this is like a real company or a scam company. So those are just weird. But yeah, I hate applying into nothingness and like having that black hole of no responses. So right now I've just been working on these data structures and algorithms, really trying to understand them, and also thinking of projects to work on that may help me. But this is probably a good idea to do because I'm completely lost otherwise. Other than the basics, I'm completely lost on how I'm going to get these interviews. Oh, look, this is actually detection of ATS readability issues. For Poland, here with such resume, you certainly get a lot of calls. But from what I'm understanding, in the U.S., there was a high. Yeah, that definitely could be the reason why I'm not getting any calls. It's a rough time right now for tech. Referrals from friends. I've reached out. I had a couple. So yeah, I just recently graduated, so I had some friends that were able to get jobs, and I reached out to them. So every time I reach out, I've been telling them, yeah, if you have any opportunities, let me know. So I'm keeping on doing that. So hopefully that'll help me out soon. But I guess I should have made more friends. But also I've been like trying to. I did a hackathon, so I tried to build a project through there. So maybe I should keep trying to do those hackathons. I just don't want to like put too much time into one spot that's not going to reap me the reward that I want, which is to get a job. So right now I've just been focusing on Leetcode the most. Yeah, be prepared for the tech interview questions. That's exactly it. Like, rather than sitting there and apply to jobs and wasting my time, you know, I would rather be just learning these Leetcode questions deeply so that when I do get the opportunity, I don't blow it. But I'm into blockchain a little bit, and Coinbase has this program coming up. So the Coinbase exchange, they have a program where they're going to take in developers to build on their network. and so it's like a mentor training program, and I've been participating and like helping the Discord, so maybe they'll accept me as a participant, and then it'll be good because I can network a little bit with senior level software engineers, and build some like I would like out of this experience to build like maybe one good project, so that I can show that I've been doing something. And since it's being mentored by a senior level software engineer, maybe they can give me guidance on how to make the project stand out. So that's another thing that I'm looking forward to. But yeah, other than that, I'm just going to keep grinding these concepts, or grinding learning these concepts, and then also the Leetcode problems. But yeah, this guy is definitely very helpful in the way he explains. I think mostly because of the animations he's doing. Yo, Wes! So Wes is one of my friends, lead coach, that is also looking for jobs, unless he got one. Companies right now also require a lot of experience, but don't realize you need to get experience if no one gives you a job. They also like to think that class projects is not experience. I had an interview like a week ago, and they asked a lot of questions about in each individual program, like what is JVM, what is the difference between JRE and JDK, and what is heap memory, what are 6 function types in Python. Plus, the computer science and programming there is a huge layoff as of late, and the market is really bad. You did not, yeah. Was that recruiter helping you? Because I got the call from the recruiter, and I talked to her, and I gave my reference. How did that experience go with that recruiter? And did you fully graduate yet, or do you still have a couple more classes? Wes? Why did this fail? Return. Okay. Fibonacci. Let's see this.
Hey programmers, Alvin here. Right now I want to show you the approach for this Fibonacci problem. And so I know you're thinking, why is he having us do basically a ripoff of Fibonacci? Well, I think it's really important that if you want to get good at these algorithm things, then you have to have a certain level of repetition. As the saying goes, one is none, right? So even though we've just done the Fibonacci problem, doesn't mean that it's completely something that we've mastered. So if anything, this should be a quick little review, right? Of course, I want you to solve this Fibonacci problem recursively. And so let's take a look at the sequence. So here is a few numbers of the Fibonacci sequence. What you'll notice is in this particular problem, like before, I want you to give me back a particular number of the sequence. So imagine that we had corresponding indices for each of these numbers. When it comes to the Fibonacci sequence, we're going to have 3 separate base cases, right? The 0th number of the sequence is 0, and also the first number of the sequence is 0, and the second number of the sequence is 1. So with those 3 seed values, we can come up with our general rule, right? Just like before, to calculate a number of the sequence or the next number of the sequence, you just take the sum of the previous 3 numbers, right? Or in general, to calculate trib of n, you do the sum of n minus 1, n minus 2, and n minus 3, and there you'll have your final answer, right? So kind of jumping at a particular spot within the sequence, if I took the sum of 4 plus 7 plus 13, that would give me exactly 24. So you should feel right at home in this particular problem. And so let's start to draw this one out. I don't want to skip any steps. And so before we start building this one, let's have some foresight and figure out how to visualize a problem like this, right? And what's great about visualizing it is that at least if we spend some time, sketching out, a structure of the problem, like visually, it can also help us figure out the complexity of this particular problem. So right now, I want to step through calculating the 5th number of the sequence, which should be 4 in the long run. So like before, I'm going to represent an instance of this problem just with a tree. And so my top level problem will be the root of this tree, right? I want to find trib of 5. And I know that I have to break this problem down into 3 subproblems, right? In other words, I can generate 3 children by doing a -1, -2, and -3, respectively.
Yeah, lead coach, isn't that what you would, are you talking about tabulation? So I know the way Alvin explains it, you would do things recursively, and then you would memoize it to make it more efficient. But then also you can think of it in terms of a table, and using a loop like you said, with the tabulation type of problem solving, you can loop through in O of n time. The recruiter was helping me to get the position, and she's doing a good job looking into other opportunities for me. I also fully graduated, so I have the master's under my resume as well, but does not seem to be all that helpful right now. Weird thing is, she reached out to me on LinkedIn and found me instead of me finding a recruiter. No, yeah, I have a lot of those, Wes, that reached out to me too. I had one that reached out to me, and she seemed like she was gonna be helpful, but then she was really like, I think she just thought I was like lying or something like that. I don't know, but she was really like questioning me a lot, to the point where it was like not even helpful anymore. So I just had a bad experience with that. But I've just been applying directly. And some others reached out to me. Dynamic programming concept, there's top-down and bottom-up approaches. Yes. So the tabulation is the bottom-up. So Wes, have you been doing any of these technical interview questions? If you want to get started, I would recommend Structy, this site, because the visual explanations are really helpful.
I'm just going to carry over that pattern for as many nodes as I can. And of course, whenever I hit like a base case, I can't break that node down any further. We know that when it comes to our Fibonacci problem, we have 3 separate base cases, right? Representing these particular return values. So I'm just going to plug in these subresults. So I should have all of these calculated values, right? 0th number is 0, first number is 0, and also the second number is 1. Now I can start reconstructing my subsolutions, right? So if I take a look at the particular, to the left, the 3 node, I take the sum of its 3 children, 1 plus 0 gives me 1, right? So the third Fibonacci number is 1. And I'll just continue this pattern, right? Every parent node just takes the sum of its 3 children return values. So I get values that look like this. And finally, at the root, I just take the sum of 2 plus 1 plus 1, which gives me a final answer of 4, right? Very similar to our classic fib problem. So this would be a working solution, basically just doing the same recursive code, except we're going to have 3 recursive calls, which makes sense because every call we make corresponds to a branch that we have in this visual tree. However, what's the complexity of this one? It's pretty slow for the same reasons our Fibonacci code was slow before, right? So if you take a look at this particular tree, I can derive the time complexity of it. So I know that for my recursive code, the time complexity is at least going to be the number of recursive calls that I make. And if every recursive call corresponds to a node of this tree, I have to figure out what the long-term pattern for the number of nodes is in this recursion tree. So I know that the height of this tree is pretty obvious. It looks like it's going to be along the order of n. And how do I know that? Well, if you look along the left-hand path, it just goes 5, 4, 3, 2. And in general, that's roughly n things, right? Now I'll just think about how many nodes are across on every level. At the top level, there's 1 node, and to get to the next level, I multiply it by 3. And I continue this pattern, right? As the tree gets bigger and bigger, from one level to the next, I would continue by tripling the number of nodes, right? Very similar to our Fibonacci problem. And so you guessed it, the complexity of this is 3 to the n, so an exponential, but with a base of 3. Right? And it is the case that our space complexity is a pretty reasonable O of n, right? Of course, we're referring to the space complexity due to the call stack, right? And in general, we can figure out the space complexity from the call stack if we draw out the tree, and we can just look at the height of the tree. The height of the tree being basically the number of levels. And there's roughly, 4 levels here, so I guess it's off by 1, even though our input was 5, right? And so to make this one a little faster, of course, we can just notice any duplicate subproblems, right? So same story like we're used to. Take a look at this subtree, rooted in 3, and I have this subtree appearing here as well. And so I want to avoid resolving that subproblem. We're going to use the same strategy as before, but this time I want to use a different word to describe it. Really what we're utilizing here is dynamic programming. So dynamic programming is really a type of problem solving where we utilize any overlapping subproblems, right? In other words, I have the subproblem of calculating the third Fibonacci number, and if I can store that information the first time I solve that problem, I can utilize it later on because I'm probably going to encounter that same subproblem. Right, so this is in the family of dynamic programming strategies, and so far we've been working with memoization. So really, memoization is just one way we can implement dynamic programming. And so if we use dynamic programming wisely, we should be able to forego that duplicate subtree, right? And overall, we'd be looking at an O of n runtime and O of n space complexity if we implemented that correctly, right? And so to implement that, of course, we're going to use some hash data structure to build that memo. So for my Python people, you're going to use like a dictionary. For my JavaScript people, you're going to use an object. For my Java people, going to use a hash map, right? Any fast lookup data structure. And at this point, we have a pretty optimal solution for this Fibonacci sequence, right? It should be able to run in a pretty decent time. And so with that, what I want you to do is give this.
All right, so it's pretty much the same thing. Let's do this. Fibonacci n. So we're going to memorize it right away. And the base case is now we have an extra base case. If n is equal to 0, we're going to return 0. If n is equal to 1, we return 1. And if n is equal to 2, we return 1. And then we say if n is in memo, we're going to return memo n. And we want to set memo n to the recursive calls of Fibonacci minus 1 and memo. And we want to do that 2 more times. I'm going to add it to minus 2. And add it to minus 3. So 3 recursive calls. And we want to return memo n. And then we just need to return the call. Fibonacci with n and an empty dictionary. So where did we fail? Here. If n is equal to 0, return 0. N is equal to return 1. N is equal to 2, return 1. What's going wrong here? Actuals 1. We're setting the memo. We're inputting empty dictionary. We're returning a value. When I prepared for my interview, I focused on interview questions. I was told the technical questions. You were not. I was told the technical questions were for the second interview, so I focused on regular interview questions. I apparently did so well, went right on into technical questions, and I blanked from then on. Was not expecting to be bombarded the last 5 minutes of my interview on technical questions. When you say technical questions, do you mean like the ones that you mentioned? Or were they more like asking you about JVM and JDK and heap memory, or were they technical questions like these questions, like to create a function or some sort of Leetcode problem? And if you did have a Leetcode problem, which one did they give you, if you remember? Me and Wes both recently graduated with a computer science degree at a university in North Carolina. It's called University of North Carolina at Charlotte. And so we're both looking for jobs right now. Why am I going wrong here? N equals 0, return 0, 1, return 1, 2, return 2. Expect 0, actual 1.
This that if you want to get good, require 3 separate base cases, right?
Oh, this one is 0, 0, 1. Oops. Okay. Wes went straight from bachelor's to master's. I actually didn't get my master's degree. They have this program called the entry level program at UNC Charlotte, and I went halfway through. So like, I'm halfway through a master's degree, but I didn't finish it out because I was trying to get a job, but maybe I should have because it's been hard. I haven't been able to get a job other than a product manager job, but not like a coding job. The thing is, though, even in the master's program, like maybe I could have taken data structures and algorithms classes and stuff like that, and I would have learned this stuff along with it. But other than that, a lot of the classes doesn't help with the actual interview process, and so, and like Wes said, he has a master's degree, and they're not even looking at it pretty much. Wes, did you have any like Leetcode questions? Write a function sum possible that takes an amount and a list of positive numbers. The function should return a boolean indicating whether or not it is possible to create the amount by summing the numbers of the list. So this is an example. Sum possible 4 plus 4 is equal to 8. Takes in an amount and a list of positive numbers. The function should return a boolean indicating whether or not it is possible to create the amount by summing numbers of the list. You may reuse numbers of the list as many times as necessary. You may assume that the target amount is non-negative. So this reminds me of a problem that I did before. Combination sum, I think it was called. And so basically, I think we do the same thing. Job market is trash right now, especially for people with less than 3 years of experience. Yep, that's me. The questions stumped me was the JVM. Didn't know Java came out with Virtual Machine in 2022, since a lot of the master's classes have been Python and machine learning. I don't know what JRE was, so I couldn't compare JRE versus JDK. I didn't know the 6 Python functions and didn't know they were looking for sum, print, add, and functions like those. I thought they were looking for something more advanced. What do you know? What was the company? Or was that the? Or was that a? Yeah, what was the company? Even if there is a technical screening, they stated that they had a training period for the position, so I would have qualified from training. Orasi? Like that? Did you get this through the school fair? It was 10 minutes from your house? Wow. That would have been nice. That would have been nice. Wes, I'm like willing to go anywhere around the country to work. I just need to get a job. I mean, ideally, I want to go somewhere where I can network because I have ideas for building projects, and I would like to meet people who want to maybe work on a project together with me. And so going to a city like, San Francisco would actually be pretty good for that, for networking with those type of people, or any city with a lot of tech in it, maybe Austin, Texas, or people that are trying to create startups. I was trying to look for jobs here, and so maybe with a good technical foundation, like once I get all these problems really well thought out in my mind, I can start direct messaging some of these people in a major city and maybe try and get a job through that for like a startup. You were thinking of taking the Reverager training program for 12 months just to have experience. The problem with those companies is that they do other weird stuff like contracts and stuff along with that training program. It's like a weird scammy thing. I don't know. It's just weird. Okay, so I think the way this works is, again, we create a recursion tree and we loop through. And we decide whether we want to keep a certain number or not. And we, at each level, we check if the sum of the numbers is equal to the target. A which company? I've never heard of that. Pro Infosys. Yeah. These are the ones, but like, it's. Did you, like, have you heard of the experience in those companies, Game Warden? These companies take up sweatshop jobs from companies in US, Europe. The thing that is your personal experience, was it awful? Was it like bearable? Was it like, do you think it's worth it? It is. It's crazy though how it's like a scam, because these companies go through these witch companies and to hire when they could just hire directly. And because if they're going to take me into this witch company and I have enough skills to get into the witch company, then and then they're just going to sell me to whatever company they're outsourcing me to. It's like, why can't these companies just directly hire me and these guys don't get a cut? It's so dumb. Or it's just irritating. They call you associate software engineer, but there is zero engineering job. People who stay in these companies for more than 4 to 5 years stay for life. My friend did one of these companies, and he works for a company called what was it called? Something with a C in North. Not Cognizant, but it was like a health insurance company. Oh, Centene. He works for Centene now, and his title is software engineer too. But he was telling me that he doesn't even code. So I don't know why that he has that title, but he doesn't code as software engineer too in Centene. You're with them now? Ah, okay. I'm FTE, so I'm getting paid regardless if I'm on a project or not. Have you done any coding with them? Game Warden? TCS. Which one was TCS? TCS. Tata Consulting. I think this is the one my friend did. Tata Consulting. Was there a contract? Like, are you like supposed to stay there for a certain amount of time? Trained in Java means that. Ah, I see. So, yeah, I'm able to reuse numbers. So since I'm able to reuse numbers, are combinations like that? Can you reuse numbers in combination? Combinations with repetition. Wait a second. You can quit at any time? Some people are joining TCS while keeping their normal STE jobs because it's such easy work. Really? Interesting. Interesting. Okay, I thought it was like some weird like thing where you can't leave, and if you leave there's a penalty. I mean, if it's easy, then I'll look into it. I didn't mean to pin. Oops. That's Ravager. Yeah, see? Wes, that's, you don't want to do that one. Yeah, I'll look into Tata Consulting. Did you learn a lot from the training? What I did was just went through YouTube, a whole tutorial on like React, Next.js, Redux, and I learned a lot even just from doing that. What is this? Codingvolution. This guy, Codevolution. I learned a lot from this guy. And I just went through the React playlist. React, Redux, React. And also, yeah, I know how to use Mongo too. And Firebase as well. I usually like to use Firebase because it's easier. All right, so we have, if we start at index 1, we have, let's say, 5. So we either choose 5 or we don't choose anything. So those are going to be the two choices. And we just keep doing that consistently. So each level is a different position. So in this level, we can choose 5 again. Or wait a second. We either choose or we don't choose. Or maybe each level is a different position. Yes, this should be a backtracking problem. I think on Leetcode it's called combination sum. But if I can remember, I think because we want to reuse numbers, so we need a system. We need a recursion tree where we can have both repeated numbers and a combination of the other numbers. Let's watch this approach video. Let's see what he does.
Hey programmers, Alvin here. Right now, let's go over the approach for this sum possible problem. So in this problem, we want to take in two arguments. We're going to be given a amount as well as an array filled with numbers. What we want to do is return true or false, indicating whether or not we can use some numbers of the array to generate the amount by adding them together. In this particular example, I should return true because I can totally make 5 by adding up some numbers in the array. There are a few different ways to do that. I could have done 2 plus 3, or 3 plus 1 plus 1, or also 2 plus 1 plus 2. And there are actually a whole bunch of other different ways you can sum up to 5. But since I have at least one way to generate 5, I'm going to return true. So overall, we're just looking for a Boolean return type for our function here. It could be the case that based on the inputs we're given, it might not be possible. So if I gave you a target amount of 15, and I gave you numbers to choose from like 6, 4, and 10, that would actually be impossible. So you should return false. All right, so how do we start attacking this one? We'll step through an example where we want to generate a target amount of 4, and we have numbers 1, 2, and 3. This should be a sufficiently large example to step through. Here, my intuition tells me that smaller amounts are easier to calculate than larger amounts. So what I can do is try to shrink my amount as much as possible until I get to a trivially small amount for which I know the answer for. So let's say I start with my amount of 4. What options do I have here? Well, if I think about my first choice, what I could do is take a 1. So this 1 is going to represent the first number I can choose, right? And what I can do from there is actually subtract that 1 from the 4. That would give me a new amount of 3. But still, at the 4 node over there, what I can do is also maybe consider taking a 2. If I do 4 minus 2, then my next amount is 2. And the final option would be taking a 3. If I do 4 minus 3, that'd give me 1. And at this point, I'm starting to shrink my problem size. So inside of the nodes in blue, we're going to have listed the amount that we're trying to break down. And then the numbers in yellow on the edges represent the choice of numbers that we choose. And we're starting to shrink our problem size. So let's say we take a look at the 3 node on the left. We can break it down further, right, using my options of 1, 2, and 3, and that would yield 2, 1, and 0, respectively. If I take a look at this 2 node over here in the middle, I have to watch out because I can only use some of my numbers for valid moves, right? In other words, I can do 2 minus 1 or 2 minus 2, and that'll give me 1 and 0 respectively. But what I should not do is 2 minus 3, right? Although I have a third option of doing a 3, that would be too large right now, and that would actually bring me to a negative quantity. So we're going to need to watch out for that in our drawing, as well as when we implement the code. Similarly, for this right-hand node of 1, I can only subtract 1 for it because using any of the other numbers would bring me to a negative quantity. So we'll continue this pattern for all of our nodes until we can't break them down any further. And this would be the complete tree. Really what we're describing is the decision tree for all of the options that we can possibly make, right? So although I'm saying tree here, I'm really referring to the fact that we're breaking this problem down recursively. When we go ahead and implement this, we're not going to have to build any like tree data structure, but we're going to solve it using recursion, right? I use this tree as a way to actually understand all of the options I can take. So since we know that this tree visualizes the recursion, where can we locate the base case? Well, that would really be just the leaves of this tree. What we can do is recognize that we have a bunch of 0 nodes over here, and to me that would be a trivially small amount that I can always know the answer for. So that's going to be my base case, right? In other words, if someone gave me an amount of 0, I'm just going to return true. Why does that make sense? Well, I can always generate 0 by just taking no elements of the numbers array. And I can always return true regardless of what numbers you give me. You can even give me no numbers and that'd be totally fine. I can still generate 0 by taking none of those numbers. And so what I'll do is jot down this return value above all of my 0 nodes. Those are going to be my base cases, right? My base case calls. And I know that if I see a single true anywhere in the tree, then it should be possible to generate the amount. Obviously here we can't really go wrong, and we have a lot of different ways to generate the amount. If you look within this tree, not only do you know that there are a bunch of different ways to make our amount of 4, but you can actually see what numbers you added to generate that amount. For example, if I look at this path, this represents doing a 1 plus 2 plus 1 to generate 4, right? I'm just adding the numbers that I have along the edges here. So this tree tells you a lot of information, and you can use it to solve a bunch of different variations of this problem. So now let's start to look at how the values return here. So given a parent node, if it receives a true from any of its children, then it's also going to return true. So that would evaluate something like this. Until we get a true at the top as our final answer. So far we've described the brute force way to calculate the answer here, and I think it's worth going through the complexity. So here I have two arguments in my function. If we say that a is the amount and n is the length of numbers, we can say that the time complexity is going to be n to the a power. So this is going to be exponential. So what we're doing here is putting n in the base of the exponent because we know given a node, it's going to give at most n children because I have to branch for every option of number in the numbers array. And I'm putting a in the exponent because I know that the height of the tree is at worst going to be a. You can easily see that in this particular example. If you start at the root and just keep going to the left, it goes 4, 3, 2, 1, 0, which would mean that the height of the tree in the worst case is exactly a, a if I had to keep subtracting 1 from my node. So overall, I'm looking at an n to the a complexity, which is an exponential and typically going to be too large to actually run for reasonably large inputs. We talk about the space complexity. It's just going to be O of a right now based on the height of our tree, right? We know the height of the visual tree would give us the maximal stack depth. So how can we do better? Well, you should probably catch the drift by now. Take a look at this tree and notice if you see any duplicate work.
2, 1, 0.
What I can notice here is I have some duplicate subtrees, right? I can see these subtrees rooted in 2 that are identical, and I even have smaller subtrees that are the same,
1,
like the ones
0.
rooted in 1. And I know that if I have duplicate subtrees in this visual, that means I'm trying to solve duplicate problems, right? If someone asks me, is it possible to generate 2 for the first time, then later on, if someone asks me again, I should have just memorized that answer, right? And so here we're going to use that memoization strategy. Just store some solutions in some cache, that way I can fetch them later on. If you implemented memoization like we've seen previously, then you would be able to trim out some branches of this tree, ending up with this smaller structure. What would this memoized complexity be? Well, we'll still say that a is the amount and n is the length of numbers. What we did was actually remove the exponential nature of this problem now. We'll say that the time complexity is O of a times n. So it's no longer an exponent. I'm simply multiplying them, right? So a still represents the number of levels within my tree, right? The height of the tree. And then n represents the width of my tree, right? For every level, I will have at most n nodes. And it would still be the case that our space complexity is O of a. We would still use a stack frames on our call stack due to the recursion. And in terms of storing our memo, we know that's also going to be linear in a. When it comes to the hash map we use to store our memo, the space complexity for that is still going to be O of a, because we're just going to use every possible amount as a key of that memo. Before I let you go, let's step through an amount that would not be possible given some numbers. So we'll step through a scenario that should return false. So my amount is 15, and I have numbers of 4, 6, and 10. If we attack this one the same way, we'll start with 15 in the root, and we'll subtract each option of number, giving us 11, 9, and 5, and I'm going to carry this over as much as I can until I can't reduce my amount anymore. So the full tree will look like this. The nodes highlighted in red are the nodes that I can't break down any further because it would bring me to a negative quantity. So if I have any remaining quantities in those red nodes, then I know that would mean those quantities are not possible to be generated. So those should be a base case that return false. And now I can evaluate my returns in the same way as usual, right? I just bubble these up to their parents. A parent is going to return true only if one of its children calls also return true. But everyone here is false, so I'll get false all the way back up the tree. All right, programmers, I think that's all I got for this approach video. What you want to do is possibly give this one a shot on your own. See if you can translate our visual diagrams into some code. And then if you get...
All right, so yeah, that was way better than what I was doing. So visually, we can look through this one. If we start out with 8, what we would have to see, let's check the possibilities. So we have 5, 12, and 4, and we see 12 is going to be greater than the number, so it's not going to work out. Other than that, we start out with the target, so that would be 8. And so once we get to this spot right here, we subtract 5 and we have 3. Oh. Subtract 5, we have 3 here. And the other side, we're going to subtract 4 and we have 4 there. No. So on this side, we're going to have 4. And so this reaches the true. So this is true. Or once we go to the next level, it'll be true. So does he show... Once it goes over, he doesn't really show that branch. So let's just delete this. Okay. So this would be another 4. And so we reach 0 at this point. So if we reach 0, that means it's true. And so we pass up the true. True. And in this direction, we can't go anymore. So if we can't go anymore, just turn this red. And we stop there. So yeah, that would be this solution. And so how can we code this? Well, let's go ahead and create a helper function. Start off def sum possible. And you have the amount, numbers, memo, you need a second parameter for the array index. Second parameter for the array index. Yeah. Well, yeah. You're right. What is, wait, so amount and numbers. Amount, numbers. And so, yeah, we need an index. Because we're gonna do a loop. So our base case is if amount is equal to 0, then we want to return true. And then we have to loop through the numbers. And we do a recursive call if we can subtract it, we'll do a recursive call. If the number is less than or equal to. I'll try that. So we loop through for I in range of the length of numbers will subtract. We'll call this thing recursive function, and we subtract the numbers I and we got to pass in numbers, and we got to pass in the current index. We pass in the memo. If amount is equal to 0, return true. Okay, so at each position, we're going to be branching out, but we only branch out if numbers I is less than or equal to the amount. And if it's not, do we just return false like this example here? We just return false. Maybe we return false, else return false. We gotta set memo n is equal, or n, memo what is the key? The amount, memo amount is equal to memo amount is equal to false, return false, or return memo. Maybe just do it at the end. This. Yeah, so what we're doing is we're looping through the array. So that's going to be each one of these branches. And on every call, we are subtracting from the amount the current index value. And we want to pass the array. Do we even need to pass the array? Do we need to pass the array? Or can we just use it? Anyways, we pass the array. And then the current index. But what would we use the index for? I am not using index right now. I'm not using index, but do I need to? Do I need to? To avoid going over all the number in every function call. So when you go into a function call, yeah, we want to, so we would want to use the current index as the beginning of the range. Something like that. Don't loop, otherwise the solution is inefficient. Don't loop, otherwise the solution is inefficient. Just consider the number at index. I mean, if I don't loop, like, so there could be multiple ways to do this, right? There could be multiple different ways to solve the problem. However, in terms of solving it visually, according to this visualization right here, I have to loop, or I have to call the recursion 3 times to make 3, or not 3, in this specific case, 3 times to make 3 different branches. So I have to loop. I have to create a loop. However, once I'm inside, and maybe I just don't need this for now. Let me try without this. Like, I understand what you're saying. Like, you could increment an index. You can go down and increment. Like, you can keep going down and then do some sort of incrementing of an index. However, it would look differently than this, I think. So I want to try and do it this way, where this returns false if the so we go down a branch if the amount is less than or equal to 0, if the, go down the branch if the current number that we're subtracting is less than or equal to that amount. If it is, then we subtract it and we go down that branch. And if we get to 0, we're going to return true. If we get to not a 0, we're going to do the same thing. But if the amount is greater than, we're going to set the memo to false. We need to set the memo equal to true here. Memo amount equal to true, and then return memo amount I'm going to try this. And then some possible. So return some possible amount numbers and memo. Empty dictionary. Okay, I got false when it should be true. Why did I get false? I got false when it should be true. So amount is 8 with this array of numbers. Amount does not equal 0. So we go to here and we say for I in range like the numbers. So I is going to be equal to 0. And we say if number I is less than or equal to 8, so 5 is less than or equal to 8. And when we do that, we now make a recursive call and we subtract 8 minus number 0, which is 5. And pass in the numbers and then pass in the memo. And we now have 5 is the amount, it's not equal to 0. Or sorry, 4 is the amount, it's not equal to 0. And we're at now index 0 again. And we check, okay, is 5 less than or equal to the amount? And if 5 is greater than the amount, then we should set that to false. And return. What am I doing wrong here? The looping will be done by the recursion. When you increment index, first the recursion right, then worry about the memo. You need to compute the OR of all of the sub problems. If it's greater, you can't use that number, but the result is not necessarily false. If it's greater, you can't use that number. Oh, yeah. So it's not necessarily false, but you can't use the number. That's true. So if it's greater than, what do I do? It's not necessarily false. If it's greater than, we just keep looping. We keep looping through all the numbers. And if through all the numbers, no. Because like if the first one is not an option, then the second one is not an option, third one is not an option. You would think that you could just now set that amount equal to false and then return the amount. Drop the else and do or in the other case. Do or in the other case. What does that mean? So I get this part here. I get what you were saying. Like, I couldn't put else here because if I put else here, then I'm just looking at the first number. For example, in the first situation where I subtract 4 the first time, then when I look at 8 minus 5, it's greater than the amount. And so I don't go into this. And so I loop again and I say minus 12. Is greater than the amount of 5 or 4, and so I don't go into it. But then we do 4 is equal to the amount of 4, and so we go into this and we should come here and 4 is equal to, or set memo amount equal to true and then return memo amount. And so if we pop up though and we set memo amount 4 equal to true, what are we doing here though? That's not good. So how do we set if it's equal to false? Maybe we do just this. If numbers I is greater, set equal to false. Okay, so some of them passed. So memo amount is equal to false at the beginning. Then what is it? What is this line equals in the loop? What is that? What is the line there? Is that or? Or equals okay. Memo amount is equal to memo amount or. Oh. Oh. What did I do last time? Hold on one second. If n in memo, return memo. So we're saying if you find a solution with any number, you just found a solution. With any number, you just found a solution. So going back to the memo amount is equal to memo amount or. So memo amount or. You're saying this? Or. Or I can do this if, like in the last one, if amount in memo, then return memo amount. Or I could put it here. if amount is equal to 0 or amount in memo. No. I don't know. Maybe I just do that. Let's try that. Nope. What was this? There's an empty case. $12 and there's nothing. That's unrelated. Oh. If amount is equal to 0, why didn't this work? So if amount is in memo, then we have it already. It's in the cache. If amount is equal to 0, we set it to true. Return the amount.
So let's step through into 9 and 5. So if I have,
And instead, or without the base cases or the cache, we loop through, and if the current index number is less than or equal to the amount, then we want to do this recursive call. We want to subtract the current index. If numbers I is greater than the amount, then it's equal to false. You're not computing the result correctly, whether you memoize it or not. You're just setting the result to the last number you tried, but maybe there was a solution using the previous number. So that's where this comes in. No. I think I understand what you're saying, but I don't know how to do it. You have to initialize memo amount before using it. So how do you initialize it? Initialize it to false. Like just off the bat. Like this. No. Before the loop. Yeah, so like that. Right before the loop. Oh shit. Okay. Well, that worked. All right, let's look at this. So So we have a base case. If amount is equal to 0, we're going to set the memo amount to true and return the memo amount. If amount in memo, if the amount is already in memo, then we return that memo amount. then if the amount is not a memo, we set it to false. We loop through the array. We check if it's less than or equal to the amount. And if it is, we're going to set the memo amount equal to that initial value or the previous value, or the next recursive call, which we subtract one of the array numbers. And if the number is greater than, then we keep looping, trying to find a number that is less than or equal to. And at the end, we return memo amount, whether it's false or true. Let's see what he says.
Hey programmers, Alvin here. Right now let's go over the Python solution for this impossible problem. So hopefully you watch the approach video here, because we're going to implement that recursive strategy and then memoize it. And so I'll start with the base case here. I know that if my amount is 0, then I can always generate 0, right? How can you generate 0? To generate an amount of 0, simply take no numbers of the array. It's sort of like the empty sum. So I would consider 0 possible as an amount, so I'm going to return true. And it's going to be true regardless of whether or not what numbers are inside. It's actually a test case over here, right? If they give me an amount of 0 and even no numbers, it's still possible, right? Just add 0 numbers of the array together, and you'll be good to go. So that's going to serve as a nice base case for me returning true. And let's go ahead and now iterate through possible numbers, right? So I'm going to iterate through all the options I can take right now. So I'm going to say for num in numbers. So this would just be iterating through this array. And what I want to do is take this first iteration of 5 and subtract it from this 8. That would give me 3, then I can make a recursive call using that 3. So here's how I work in my recursion. I call the same function sum possible, give it my next amount, which I'm going to get by doing amount, the current one, right, and subtracting num from it. So again, what's happening here, let's say we're in this scenario where amount is 8 and my num is 5. I do 8 minus 5, so I'm passing 3 into this recursive call. Then I'm asking is 3 possible using the numbers of the array. And so what we'll do here is also be sure to pass in the same numbers. I don't need to modify the numbers list because they tell me that I can reuse numbers as many times as I need. So that should be good to go. But now what I want to do is think about the return type of this function, right? So here's what I do in my recursive leap of faith. I'm going to assume my function's working. And if this call worked, then I would get back a Boolean, right? Telling me whether or not this quantity is possible, right? Can I make this quantity? And I'll check if that is true, if that quantity is possible, be explicit here, then what I should do is also return true. On the flip side, let's say that this call returned false. Well, then I just want to go to the next iteration of this for loop and check if the next number is a better choice. That means after our for loop, we do want to return false, right? That would mean that, all right, it's not possible to actually use any of these numbers in a way that would lead to my amounts being made, right, being summed up. So it's a very common programming pattern, right, doing some recursion as well as some if statement inside in our loop. And what we want to do here is watch out for some errors, right? In some scenarios, maybe like this example over here, let's say that my current amount is 8, and I'm on the iteration of the for loop where my num is 12. And so if I do 8 minus 12, I'll get negative 4, and then from there, if I keep subtracting numbers of this array, I'll only get more and more negative numbers, and that can give me some infinite recursion. So what you could do is, if you wanted to, you can check an if statement here and also check maybe around it, or just use an and. You can always check if your number is less than or equal to your amount. That would be a fine way to implement it. What I'll choose to do here, and my favorite way to implement this pattern, is to actually add a base case. I'll just go ahead up here, check if my amount ever reaches something less than 0, then I can return false. Notice that this still catches this scenario, because let's say I did pass negative 4 over here. Well then, in that call, I know it would automatically return false, and then I'll just skip over that number and go on to the next number. All right, I think we're ready to go ahead and test this one. Let's give it a shot together. So we'll give that a test run. We expect this to at least time out.
So this one, he did it a little bit different. I guess he didn't use the or because he was saying, making it an if statement. And so when it comes back, he's checking, he's doing the or with that if statement. So if it's false, then it's going to return false. And so it's like he's doing the or. It's just a different way to do it.
A brute force solution, right? So we pass a bunch of test cases, but toward the last few test cases, they give us some pretty large inputs, right? So if we look at test 07, that's the first thing I time out on. So I'm not giving any incorrect answer. It just takes too long, right? Example 7 has me find a sum for 271. which isn't really a large number, but in the context of the runtime of our algorithm, it could be some large quantity, right? Something we can recognize about this function right now is it's going to have an exponential runtime. If we say that a is the amount and n is the length of the numbers, I will have an n to the a runtime, which is exponential. And typically exponential functions are going to have a way too large growth. So to fix this, we'll use that memoization strategy, which is one way we can implement dynamic programming. And it'll be our go-to, I think, for much of this course. So what I can do here is maybe break out into a helper function, because I know I need to give a nice memo dictionary to this recursion, right? So maybe I'll rename this function, be careful with my refactor here, to underscore, it's impossible. Then in my main function, I can just redefine it, because I do want a function with this exact name so they can run the test cases. And the upshot of this is I can now return maybe just a call to
What do you mean? Why did you make that comment? Is that something that you haven't seen, or like something that's weird? Equals to true. I think I understand what he's doing here. Like, I've seen him do it before. That's probably why I understand. But yeah, he's saying whatever returns, you check if it's true or false. Because that's what you're trying to do. I guess, like when you're when you return here into this one, into the next level up, you want to know if the previous one was true. Yeah. I think it's just to make it more explicit. I know what you mean there. I think it was just to make it more explicit. But yeah, like, if whatever returns, if it's false, then don't do anything and just return false. But
that helper function, and I can give it some
true.
proper arguments, right? So some possible, pass along the amount in numbers, that's fine, and then give it an empty dictionary to be this memo. Nice.
Yeah,
now I actually want to use this memo. So some classic base cases. By now, this should be a familiar pattern, right? Being very inspired by patterns like fib. To me, it's a really core recursive pattern. What I want to do here is check if the amount is in the memo. Keys of my memo dictionary are going to be the amount. And how do I know to make it the amount and not the numbers? Well, amount is actually the thing that changes over time, right? I actually make amount smaller and smaller by subtracting from it. I can reuse numbers as much as possible so they don't change, right? So it's really the amount that drives the result of these recursive calls, right? So if the amount is in the memo as a key, then I want to return the stored value. So I'll return memo at amount. So this will get the corresponding value from that dictionary. Now what I want to be sure to do is pass this memo along to these recursive calls, because I want it to be shared by the entire recursion tree. And then I need to actually write some lines that store information in the memo. And what I always do is I look at my non-base case code, so I look at the recursive portion of my code, and whenever I had a return statement, I'm going to actually store that value into the memo first before returning. So that would look like this. I look at this first return, and right before I return, take that value and put it as the value inside of the memo. So I'll say memo at amount. An important thing to do here, I always, if I do this recursively, want to store the key as the plain argument. So I'm not going to do something like this. This is not what you should do. Because with memoization, what you're saying is, as the values of my memo, I want to store the result for this recursive call. And this recursive call is about amount. Right? If you wrote it about amount minus num, then technically you're expressing it about your child recursive call. So you want to do it just like this. Just take your plain argument, add that in. Then I'll do something very similar for this return false. That'll be a nice recipe we can always use. So I'm storing information in this memo in case someone needs it later on. In other words, if someone encounters this same amount, well, then I have this information. They don't need to recalculate it fully. Just look at this memo, because if it's a dictionary, it's a constant time insertion, but also a constant time lookup over here. So let's see this run now. Awesome, and there's a perfect solution for this sum possible problem. At this point, we brought our runtime down from an exponential down to a linear, so I would be looking at an a times n.
So these two return false. Instead of putting it directly in here, you put it inside of this if statement. Okay.
Runtime. Space complexity here is also going to be a linear in the amount. That's because if you think about it, I store a different keys within my dictionary over time, and even in terms of the recursive call stack used, I know in the worst case the height or the maximal stack depth of that recursion is going to be a, right? Imagine the worst case, I kept doing -1 as my numbers, in which case the height of the tree would be exactly a. All right, programmers, I really want you to practice this pattern because we're going to do a lot of similar dynamic programming problems coming right up. So this is
When you say drop the loop and make it more efficient,
So if I have any, not going to have any room
more efficient
option
than
of
this.
So we'll step through, start break,
complexity
bring me
here?
to a return true else. So I'll get ramps into some code, and then if you get stuck, you can find me in
Hold on.
nodes.
Like the time complexity of the code that I just did would be what we see here. It would be the height of the tree, or the amount, and the length of times the length of the numbers. That would be the time complexity. So if we drop the loop, is it going to be less than that? And what would be the time complexity by dropping the loop? Yeah, we can go to the next one. Min change. Write a function, min change. That takes in the amount and a list of coins. The function should return the minimum number of coins required to create the amount. You may use each coin as many times as necessary. If it's not possible to create the amount, return -1. So it seems similar to the previous problem, but this time we need to return the coins. So each number is a coin, and we want to return the total amount of coins. So basically the sum with the smallest amount of numbers required to add to that. And so instead of just returning true or false, now we're going to have to keep track of how many numbers or the height of the tree to get to that point. And so we probably need to have a counter. So there's a guy doing 1v1 challenge requests in elite rooms. That seems fun. I can't wait till I get to that point where I can challenge other people and be a little bit quicker with it. I think that'll be fun. I like thinking through these problems, and I feel it makes me feel good being able to do them. If you guys want to do elite rooms, I'm down right now. Oh wait, how do I do it? Oh yeah, right here. If you guys are trying to code. But yeah, let me know. If you guys want to do elite rooms. Yeah, so this is going to be a similar problem. We're going to create a tree just like this. But instead of passing up true or false, we're going to pass up a count. So we have 8 to start, and we're still going to do the same thing where we only branch if it is less than the number. So 154. You're always down for lead rooms? Hell yeah. Game warden, or is it game warden? When you said you do personal projects or you're doing side projects, are you working on anything right now? And would you be down to work on something? If you're open to looking into new projects, I'm trying to build a project right now that I want to make into a company. And basically, there's these apps like Ome TV, and it has like 200,000 users on this app. And they have something called like Hey.Fun that has a bunch of users, 21,000 on this site. And I want to build like a clone of this, or an actual social media with the same concept. Like I want to build a social media with peer-to-peer random video chat, but make it way better than these. Like I was thinking the first idea to expand on what already exists is to have this popular dating show aspect to it. So instead of you just having a call with a person, there's prompts that make it similar to this show right here called The Button. So you're put face to face in front of someone, and you're kind of locked in, so you can't skip them right away. And if you you're talking to them, and there's a prompt that comes up that like sparks questions, and so like you're supposed to go through the prompts, and then if the room lights up, you can skip, or if you like the person, you can keep talking, and it kind of plays out like this game. And so the idea is to create a whole social media based on peer-to-peer random video chats, but expanding on just talking to a person and adding different features that make it more engaging and more fun. And the first type of example would be this type of game. However, I have like multiple ideas where you can make it more engaging and fun. Another thing I wanted to do is, again, these rooms have just you talk to someone, but like now there's newer technology that can make this better. So like you can use AI and have real-time translation. There's a lot of foreign people that like to talk to each other. And so if we were to create an app like this, but then add real-time voice to caption translation, then a lot of the people that go on this to talk to people from other countries would go on our app. So yeah, that's one of the projects I want to work on. I think it's a cool project because you're using WebRTC, and I think that it could get real users right away if done correctly, because you already have this big user base on apps like these that, and these apps are just bare minimum of what you could do. But yeah, that's one of the projects that I was working on. And I want someone to work with me that knows Merge Stack, or I'm using Firebase and Next.js And so, yeah, what I need to do now. I pretty much created the login feature and the main screen, but I need to make the main screen look better with React, Next.js, and then I also need to work on the matchmaking system using Firebase functions. So that's the two things I'm working on right now. But yeah, let me see this thing right quick. Normalization. Binary search tree, array. All right, I created this room. If you want to join, we can do this. I'm gonna use the bathroom real quick. divide players into teams of equal skill. You're given a positive integer array skill of even length n, where skill I denotes the skill of the ith player. Divide the players into n divided by 2 teams of size 2, such that the total skill of each team is equal. The chemistry of a team is equal to the product of the skills of the players of the team. Return the sum of the chemistry of all the teams, or return -1. Return the sum of all the teams. So there's 2 teams, return the sum of them both, or return -1. There is no way to divide the players into teams such that the total skill of each team is equal. Oh, you solved it. Nice. You're given a positive integer array skill of even length n, where skill I denotes. So we have this array. We have output is 22. Divide the players into the following teams: 1, 5, 2, 4, 3, 3, where each team has a total skill of 6. The sum of all teams is 1 times 5 plus 2 times 4. Oh, the teams are only 2 people. So teams are only 2 people. 2, 4, 6. Is there always going to be an even number? Yeah, the skill is the, yeah. So there's always going to be an even number of people. And their skill is 1 to 1,000. Their skill is the product. The total skill of each team is equal. The chemistry of a team is equal to the product of the skills. What is the total, such that the total skill of each team is equal? I mean, in this scenario, we have 1 and 5, so that's 5, 8, 9. So that's not necessarily equal. What does equal mean? The 2 players form a team with a total skill of 7. The chemistry of the team is 12. Oh, the total skill is the addition. And the chemistry is the product. So the addition, we want to split the team into teams where they have equal skill, total skill. How do we find that? Maybe some sort of target we need. Like, how do we know what total skill we're aiming for? Skill input. Yes. 1 plus 5 is equal to 6, 2 plus 4 is equal to 6, 3 plus 3 is equal to 6. Yeah, so that's the total skill. So I think now I gotta figure out, how do I find the total skill so I know, like, I want it to be all of that amount. How do I find that total skill? I think that's the next problem. Since each number was used exactly once, we have 6 plus 6 plus 6 is equal to 18. Is that the sum of them all? 9, 12, 13, 15, 18. Yeah. No, I understand. What I'm thinking is maybe to find the target number of what needs to be the total skill, maybe adding doing the average, because the sum is 18, and so 18 divided by 3 would be 6, divided by like the pair, like you were saying, the pairs. It's not really the average, but like average in terms of teams. Or the average times 2. We want to form n divided by 2 teams. N divided by 2 teams. Which for this specific example is 2, 4, 6 is 3. 3 is a specific example. So, yeah, so 3. So 1863 sounds familiar from times tables in school. 1863. 1863 sounds familiar in times tables. That one lost me. Three times 6 is 18. Yeah, but okay, sure. But what are you trying to get at? So you're trying to say that we take the sum of them all, divide it by 3 teams, and divided by 2. All right? That's to find the total skill, and then we gotta solve the problem with total skill, right? Or you're talking about something else? Like total skill is equal to the sum of skill divided by n over 2. So in this case, total skill is equal to 18 divided by 6 over 2. Total skill is equal to 6. And so with that, now we have a target. And so what can we do with that target? We have to find 2 numbers that add up to that target. And then we can't use those numbers anymore. And we got to find another 2 numbers. And another 2 numbers. And so, Lumax joined the room. Hello, Lumax. There's no way to divide, so there could be no way to divide it so that all teams are equal. And that would be -1. Or one way. But how do we find if always? Maybe we do like a hash map. And we could take the target sum and we subtract. And then we find the difference. As we loop through. For each one. And instead of returning like the first one, if there is a match, then we set the pair. And if there's not a match, then we put it into the hash map. So maybe that, let's think that through. So we create a hash map. What would be the key and the value? what would be the key and the value of the hash map? Total skill. So we want to loop through. I want to check, okay, is we subtract total skill with that number and we say, is that in the hash map? Right? So the key would be total skill minus num. And we check to see, is this in the hash map? And if it's not in the hash map, we have to enter it in. And what would be the value that we're entering in? The current index, right? Or the number. Whatever that difference is. Or the difference is the key. Found this platform code battle in, although looks quite early stage. Ooh. It's a new one? Whoa. So it's like already built in. It's like the Leet rooms thing. And there's active rooms. Oh shoot, there's people in there and stuff. That's cool. Thank you for sharing this. And there's the leaderboard. Wow, this is cool. Let me bookmark this. I can create a room in there next. That's cool. Yeah, after we're done, we're right now we have this we have Leet rooms open. So after I'm done with this, I can start a room in there. But yeah. All right, so we're going to loop through the array. We're going to check to see if number's in the hash. If not, we're going to input the number. But we have to subtract. Maybe that's, so the key is the difference. Because then when we go along, the key is the difference. And the value is the num. Is num. And then when we should the value be num or should the value be something else? I think num's okay. And then let's say we find it. So once we find the value and we're going to return, or what we're going to do is sum up, or we're going to take the product of the key and the value. So let's say we stumble across the difference. Then we take this difference and multiply it by the previous value that was stored in there. And yeah, that's how we'll do it. So maybe we can loop through and try and figure this out. So on the first number, 6 minus 3 is 3. So 3. 6 minus 3 equal 3. And the number is also 3. All right, so that's 1. And we loop through, and 2 is not in there, so we do it again. 2, 4. And then we have 2 here. So we have a key of 4, value of 2. And we have again 5. So this would be 1. And 5 is the R. So we just do 5. Keep going. And so 6 minus 1 is equal to 5. Wait, am I doing this right? So 6 minus 5 is equal to 1. So that's the key, and the value is 5. 6 minus 1 is equal to 5. Shouldn't this be a match? What am I doing wrong here? What am I doing wrong here? So the number that we're subtracting is 5. Total skill minus 5 is equal to 1. So we're looking for 1. Oh yeah, so the thing is we have to check. So we're doing a check before we enter it in, and the check is it in the dictionary? So we have the check, it's in the hash table, and so if it's in the hash table, then we pair it up, right? So at this point, it's a match. So we pair it up. And what are we doing? We're taking the num and the value. So num and num is going to be 1 and table num. So num and table num, that's going to be a hit on this index. It's going to be a hit on this index. And then for the next iterations, 3 is also going to be a hit, and you're going to have 3. And 4 is also going to be a hit, and you have 2. So that works. So you have to create a hash table with the total skill subtracted by the number. And, okay, is there anything else I have to do? I think that's it. So let's try that. Total skill is equal to the length of the, oh no, not the length, the sum. You just do sum of skill divided by the length of skill divided by 2. Print total skill. Total skill is equal to 6. Right. We do like this. Or how about this? What does this do? No. Return to integer. Okay. So we have total skill, and then we want to loop for n in nums. And we also need a dictionary called table. And we want to say for n in nums, if n in table, then we want to, so what we're doing is finding the pair where, oh, we also have like a sum. So what is the output is going to be sum chemistry is equal to 0. And for n in table, if n is in table, we want to take n, multiply it by table n, and add it to the sum. Sum chemistry is equal table n. Else it's not in the table. And so what we're going to do is we're going to put it in the table. We're going to say table n is equal to n. Or table Wait a second. What I'm doing is not n. What I'm doing is checking if total skill minus n is in the table. That's what I was doing. Total skill minus n is in the table. Then we take n and multiply it by, wait, do we take n? Because n is going to be, n should be in the table. We need to take total skill minus n and multiply it by n. Else we need to put total skill minus n into the dictionary and n as skill is the proper s in skill, total skill minus s, put s. So yeah, so this is the chemistry. We're summing up the chemistry if we do find it. Okay, now how do we return -1 if there's no way? If there's no way to divide the players into such teams such that the total skill of each team is equal, how do we find that? This is the question. Or is that implicitly found somehow? So for essence skill, we do that, or we do that. And at the end of it all, two plus 2 is 4, plus 3 is 7. Do we just go if total skill is odd? If total skill mod 2 is not equal to 0, then return -1. Else return some chemistry. I don't know. No. Let's see. con el... Output 9 expected 22. Case 3 was right. This output is... Oh. So that's not enough. This is not enough. How do we find if it's possible? How do we find if it's possible? Well, what we're doing is we're taking the sum of all the skills. So if it's divisible by the teams, then it is possible, right? However, this one is a different scenario. This one is different because there's only one pair. Is that just an extra base case? Not a base case, but a edge case. It's odd, but it only has one pair. Maybe I just put if total skill is odd and this is greater than 1. So now we have an output 0. So we're starting fresh. We have 0 here. We have 2 numbers. And we say if total skill, well, the problem is here. What if we had like 4 numbers, 2, 1, 2, 1. Maybe it's just outright different for Let me try this. So if the amount of teams is greater than 1, we want to do this total skill. Check divisibility before making the division, yeah. How do you get into this room? The code is in the top right. But yeah, I just pasted it. And so check divisibility right here. So if it's greater than 1, we want to do this total skill. Else, maybe total skill is equal to sum skill. And -1. Because I'm doing this. To do x, y check, x mod, x divided by y check, x mod is equal to 0 first. To do x divided by y, check if x mod y is equal to 0. And if it's not equal to 0, do I return -1? Is that what I'm doing there? Doing this. But what do I do if they don't equal to 0? If they don't equal to 0, pay attention to what x and y are. I mean, is x and y the sum of the skill and the amount of teams? If you can't divide, then you can add integer numbers that add up to it. And you can't. Is that what you meant to say? Then you can't add it. So you return -1. So but what about this case right here where I needed maybe we would do this and equal to sum of skill and teams is equal to of skill divided by 2. You could use integer division in Python with double slash. Yeah, that's what I thought, but then I got like I thought I got a float number when I ran it, but I may have saw. So skill sum mod teams equal to 0. Then do this. So if the number of teams is greater than 1 and skill sum mod teams is equal to 0, or is equal to 0, there's no remainder. If it's equal to 0, then be set to total skill, else well, when do we turn -1? You don't need to handle the case of one team separately. Well, okay, so let's say I do this, right? And we just do that. When there's one team, like let's say we have this right here is 3, 4. 3 plus 4 is 7. Mod teams is 1. Or 7, you know, it can be equal to 0, right? 7 mod 1. Or no. Yeah. 7 mod 1 is equal to 0. And so if it's not 0, return -1. Well, in this case, oh, wait, maybe I fixed it. Length of skill divided by 2. And so, wait, so if it's not 0, return -1. It's not 0, return -1. So return -1. See, like, why am I... What is this float number? That's from multiplication. 3, 4 is equal to 0. You're not using slash. Oh, in terms of this? Where else am I using? Let me turn on my fan. There's still an occurrence. Oh, fuck. Let's see. So it should remove that. Okay. So why am I getting 0 on this one? Okay, so we have 3, 4. So the skill sum is 7. And the number of teams is 1. Then we set the total skill equal to 0. And we say if the skill sum, which is 7, mod teams is equal to 0, or sorry, teams is equal to 1 is equal to 0, and it is. So with that being said, we have 7 divided by 1. So total skill should be equal to 7. And sum chemistry is equal to 0. And for essence skill, if 7 minus 3 is in table, so it's not. So we do 7 minus 3 is 4, and we put 3 as the value. And we loop again and we say, is 4 in table? No. Is 7 minus 4 in table? Seven minus 3 is 4. 4, 3 is 4 in table. And if it's in the table, then we check to see, then if it's in the table, if 4 is in the table, multiply 4 by the value of the table. Is that it? Two, 2, 2, 2, 2. Output is 12 and expected 8. Why? Two, 2, 2, 2, 2. So we have two teams. Skill sum is equal to 8. Team is equal to 2. 8 divided by 2 is going to be 0. Or mod 0. 8 divided by 2. Eight divided by 2 is equal to 4. So each total skill has to be 4. You put 2 into the table. If so for 2, if 2 is in the table, it's not in the table. Then you put 4 minus 2, so 2 is equal to 2. So the key is 2 and the value is 2. You loop around to the next one. The key is in the table. And so I see. So I probably have to, once I create the team, I have to remove the person from the hash table. Right? So delete. Is this how it works? Delete table S. Delete key in hash table Python. Delete table S. That makes sense. And so now we have another one where it's not returning -1. Why? Well, in this case it is even. 6 and 4 is, so in this case it'll the sum is 4 plus 6 is 10, and the teams are 2, so that's going to pass this condition, so it won't return -1. However, it's not going to so maybe we do another condition and we say if the mod is 0, then we do the division. And then if total skill yeah, how do we find this? How do we find this? So now we have 4 teams. One's going to be 7-3 or 6-4. But they're not going to be even. So maybe we just have to have a condition elsewhere. Maybe we have a condition that checks before we add. Like right here, if the chemistry, so we just do chemistry is equal to this value here, and we say if chemistry is not equal to total skill, then return -1. And I'm still wrong. I probably just did that wrong. This is another case where the whole thing, 5, 10, 11, 14, 18, where the whole thing could be 6 each. Oh wait, I output -1. No, I'm wait. Three, 6, 6, and 6, right? Expected 22 and output -1. What did I do here? So I'm saying if it's in the table, then we're going to add the chemistry, right? But we want to check if the chemistry is equal to total skill. Oh, but yeah. And if it's not, then doesn't it mean we return -1? How does it even get there if it's not equal? Return to the example and stare at it. You should be able to see it. The solution is much simpler without using a table, a hash table, or like you use the hash table and maybe just the conditions. It's easier in the conditions part of it. Wait, what am I doing wrong here? You're assuming that you always find a solution if the first condition is true. And I'm not always finding a solution because of situations like this. So basically I have to return -1 if definitely without a hash table. Oh my gosh. Well, I'm too far gone with the hash table now. If you have 1 1 2 2, you can, but with 1 1 1 3 you can't, even though the sum is the same. Yeah. So basically I gotta return -1 if there isn't X amount of teams found. Like if the team like maybe I have like a team count. Or like after I'm done using these teams, I go, okay, teams -1. I don't know. Teams -1. And return if teams equal 0, return some chemistry, or else return -1. This one is 10, 12, 16, 21. And it returns -1. Why? -21, 3. Should be equal to 7. No, I messed this up. I meant to say... Alright, Mohita, thank you for joining. Or Mohit. The idea is correct, but I'm not implementing it. What I was trying to do is say if the entry was found in the table, we want to decrement the team because we're about to add it. It's one team down. For example, 7 minus 2 is 5. 7 minus 3 is 4. So we find 4. And we add their chemistry. And then we decrement teams by 1. So now we have 2 left. And then 7 minus 2 is another 5. So I have a problem here where I can't, maybe we delete the entry. Or like, the problem here is I have 2 entries. The same key. So how do I... That's not good. It's a collision. But it's the same value. So how do I do that? If it's the same key, how do I do that? Because it's the same key, there's going to be a problem. Norrell, join the room. Alright, he's going to finish this. You need to consider duplicate elements and elements paired with themselves. Yes. Duplicate elements and elements paired with themselves. Alright, let's see what game warden did. I give up. Oh wait. Didn't he submit it? Oh, right here, solution. He was doing something different. He sorted and he set 2 pointers and then he checked. Yeah, that is a way to do it. Yeah. That is a way to do it. That is a way to do it. Yeah. So I'm just stuck because now, like, I was trying to delete an entry if there was a duplicate, but then I didn't realize that, like, if you're adding the same key, how is there even a duplicate? It just doesn't, it just replaces it. So how do I deal with the fact that there's the same key? And yeah. All right, let's see. Midnight. Yeah, I don't need to change the hash symbol. Yeah, I understand that. Okay. This is C++. Midnight, do you stream? I think I was watching your stream the other night. You were doing Leet rooms, right? Decorate and remove if 0. So this is this a hash map? Is it a hash map? And target. Okay, wait, let's go to divide players. And it's skill.size. Total teams is n divided by 2. Total skill is equal to 0. Create a map. And then we say for X skill. So for each one, we we're just populating the total skill and what is this doing? Frequency map X plus plus. So we're adding that skill into, I see. We're adding the skill point into the map with the value of 1, I think. And then, so this keeps track of how many there are. And then target skill is equal to total skill divided by total teams. But if this is not 0, we return -1. And then for X and skill, so for each one, we have to find in the map continue if it's equal to the end. So if you reach the end and nothing was found, continue. Partner's skill is equal to target skill minus X. Okay, so you find the partner skill is equal to the end. So if you can't find the partner skill, you return -1. And if you can, oh wait, decrement and remove if 0. Decrement and remove if 0. Return -1. I don't get these return -1s. Here's my 2 cents in Kotlin since I couldn't join the room because I couldn't figure it out. So yeah, this is the mod. You return -1 if it's not 0. Okay. Take this total skill, number of teams. If total skill remainder number of teams does not equal to 0, return -1. So if the skill size does not equal to 0, remainder 2 does not equal to 0, return -1. I think this is always even in the thing. But anyway, so this, and you sorted, yeah. You did a sort, and then you did the left pointer, right pointer thing. Right? What is team skill? If, yeah, the current index and then the last, yeah, any increment inward. Okay. And let's see Norals. How do I a scoreboard? Normal. Oh, I can't see. No. Okay. So I saw the way Midnight did it. I can't fully understand it, but like from what it looks like, instead of putting like the values in the table like I did, he put a counter for how many duplicates there are. And so let's see if I could if I were to do that, like instead of doing what I did, if I were to put like a number, a count, then what would I do? Hmm. So let me do this again. Teams minus equal to 1. And then I have to figure out how to deal with the duplicates. Maybe I hold a value as a pair of numbers. And then we say if S is in table and the second one of that value is equal to 0, then we delete it from the table, otherwise. Maybe I could do that. Maybe I could do that. So instead of setting this as just a value, I can do S, comma, S, comma, count. How do I do that? I don't know if I can do that. Like I wanted to set a pair of numbers, one being the value and another being the count of how many of those values were recorded. But is there an easier way to do that? I mean, I tried to handle duplicates or handle I tried to handle duplicates by deleting it from the table. What if I just didn't delete it from the table? And instead I said if S in table and teams greater than 0. I'm getting closer, I feel like. Expected -1 and got 270. You need to make sure that for all pairs, ij, SI plus SJ is equal to smallest plus largest value in S. Once you validate this, you just proceed to pair all of them. Pairs ij, SI plus SJ is equal to the smallest, largest value. Yeah, that was the other solution, is sorting it. But I didn't go with that. I didn't think of that. I could have thought of that. But I thought to use this hash map and instead to find a sum that is equal to the total skill. However, I gotta deal with duplicates, and what I'm trying to do here, what I thought would be okay, is saying if we find a value in the table and the teams is still greater than 0, because if teams is 0, then we don't want to keep potentially finding duplicate pairs. But here we're supposed to get -1 and we get 270. And supposed to return -1. So where do we return -1? We return -1 if the skill sum divided by the teams. So there's 4 teams. So if skill sum divided by teams is equal to 0, 12, 21, 36, 52, 66, 76. So 76 divided by 4. What's the issue I'm having with dupes? I think I'm just not checking like when I enter into the hash, I'm entering 2 keys with the same value. Or same two keys that have the same value, or the same key value. You suggest I go with the most natural solution? I mean, I could. But I'm already too far deep into this. like I understand the natural solution. I get it. It's you sort the array, and like you said, when you sort the array, you're now saying you're now able to pair the largest with the smallest, and so you have the two indexes on right and left, and you just add the two, or you know do the chemistry and then you add them and they move in. Chemistry, add them, move in. So I understand that solution, but I guess I started with this because I thought, oh, okay, if I use the hash map, it'd be faster, right? But I'm having trouble because I'm not passing edge cases. So this right here, put this in the hash map, put this into the hash map, or 19 is 9, 5, 3, 4, I don't get how we returned. Print teams. I don't get how we returned 270. It should return -1, no? Teams is 0. So that means it decremented. Why? That means it decremented. That means it got into here and it decremented. Oh, because by the time it gets here it was 1. Yeah. So with the hash, I basically create a counter of the skills and check for that skill S. Count S is equal to count team skill minus S. And check that for every skill S. Create a counter of the skills. Is that like when you say create a counter, is that like another hash table? to like counter. So let me remove this. It's a Python collection. Python collection counter. From collections import counter. Counter is equal to counter. How does this work? How do we add to it? Count is equal to counter skills, then you use it like an array. Count S is equal to target S. So count is equal to counter skills. Then use it like an array. Count S is equal to count target minus S. What is count target minus S? You still need to do the first part to compute total skill. Okay. So I computed total skill. I have this counter. So the thing is, am I still holding the table? And how does it work in conjunction with the table? Or do I just have a count now? Your only table is gonna be the counter. Okay. However, but I see. Yeah, I could have just thought of that in the first place. I don't know why I didn't think of that. Hold on one second. Like I just had a brain fart. So basically, we're doing count S is equal to count target S. But so what we're doing is we're trying to see if it's in the table, right? Or if it's in count. Or is that not what we're doing? Instead, we're doing if count S is equal to target S or total skill. If count S is equal to count total skill. You just want to know if they're exactly the same amount of values that pair with S. Just want to know if they're exactly the same amount of values that pair with S. Minus S. Count S is equal to total. Do we do this? All threes must be real fast. Let me see your solution. No. Smallest, largest. Target is equal to smallest plus largest. And then you're looping through the count. Y is equal to target. So it's the smallest and largest minus X. And if count Y is equal to 0, return -1. If X is equal to Y, return -1. X is less than Y. Oh, my brain's not working right now. I gotta read this another time. Gosh. Alright. I can't figure it out right now. I need to take a break, guys. Thank you for coming and watching. I'll come check out your streams, Leetcode and Midnight, and I'll go and watch your streams later. But I'm gonna take a break for today, and I'll be back on another time. Thank you guys for joining me. Yeah, Code Battle. This seems cool though because they have the matchmaking, or like you can just join a room. So we can try that next time I'm on, or when I'm on your guys' stream. But yeah, thank you for joining me. Thank you for helping out. I'll be back on later, tomorrow probably. Hello, Emma. I'm just getting off. I'm doing good. How are you? Are you playing any games? Are you playing there's one game that's good right now. I think it's Arch World. Are you playing this game? I think there's a good way to earn in this game. You're busy? Yeah. I'm trying to do this coding. These coding interview questions so that I can pass the technical interviews and get a job. So this is what I've been working on. Also, like I was telling Worden, I'm trying to build a clone of Ome TV. And so that's a side project I've been working on. And so once I build this, I'm going to try and get people through these sites to join mine. But yeah, I'm trying to build a clone of this because I think this is a good way. Like if I can build a really good clone of this site, that I can make into an actual social media that can make money. Maybe through advertisements. Almost like a Twitch if they talk to each other long enough. So I'm gonna try that as a project. Or as a startup. Alright. Thanks for the help, everybody. I want to be on tomorrow. Have a good night.